like to find the volume of the solid obtained by revolving the area that you see here, bounded by these curves, y equals 2 minus x squared, x equals 0, x equals 1 in the x-axis, and we want to rotate this around the x-axis. That's going to give rise to a region. We want to find what the volume of this is. I'm not going to go through why the picture looks like it is. You can use a graphing program or anything that you have at your disposal to find this out. But what we will do is we're going to take the region and divide it into smaller pieces and figure out how big each of those pieces are. So if we divide it along the x-axis, so for each particular x value, we're going to take each of these small rectangles and rotate them around the x-axis and see what shape we get. First thing we do is we figure out our bounds on x. So the smallest x can be is going to be 0, and the largest x can be is going to be 1. So for 0 less than or equal to x is less than or equal to 1, each of these x's is going to give rise to a rectangle, and the rectangle, when it's rotated around the x-axis, is going to look something like this, like a disk. Just like with Riemann sums, we're going to take each of these small little pieces, add them together, and then take a limit. That limit's going to give rise to an integral, and the integral is going to be something we can compute. The width of each of these is going to be this small delta x. The rest of the volume can be found as long as we know the radius. The radius can be found for a particular x value by looking at the rectangle that we drew. In this case, the radius is going to be given by the function itself, which is 2 minus x squared. We know this is the radius because this is the curve that we started with, and that gives the height of the rectangle. Once we have these, the volume for each value of x is going to just be given by the volume of a cylinder, which will be pi times the radius squared, so pi times 2 minus x squared squared, times the width, which is delta x. Once we take all of these and we add them all up, we end up with an approximate volume. In taking the limit, we end up with an integral. And because our x values range from 0 to 1, what we end up with is the integral for all the possible x values, so between 0 and 1, of the limit of each of these parts. So in this case, we have the integral from 0 to 1 of pi times 2 minus x squared squared dx. All we have to do now is compute this integral. And so, if you look at this integral, we might want to use substitution, but there is no x outside of the square in order to use substitution with. And so what we have to do instead is simplify the integrand by multiplying out the square. So I have pi times the integral from 0 to 1 of 4 minus 4x squared plus x to the 4th dx. And now this is just a polynomial. We can find the antiderivative. So I get pi times the antiderivative of 4, which is 4x, minus the antiderivative, so 4/3 x cubed, plus 1/5 x to the 5th. We're going to evaluate this between 0 and 1. When you plug in 0, you get 0. So all that's going to come from this is what happens when we plug in 1. And when you do plug in 1, you end up with pi times 4 minus 4/3 plus 1/5, which, after you simplify, get your common denominator, and combine things together, you end up with 43 pi over 15. And that is the exact volume of the region that we have.